Hello, my name is METİN. This is 110th part of explanation of my theory, according to my theory and my formulas. Galileo-Einstein free fall illusion depends on mass. G, gravity acceleration unit, depends on masses of free fall bodies. How do you know free falling bodies' acceleration independent of their masses? 1. Again, go back. Pisa Free Fall Experiment. The hand that holds two objects. Now, two objects, okay. We add second object. And then we can do that. Yeah, two different masses, two objects. Again, go back, Pisa Free Fall Experiment. The hand that holds two objects that are different masses is rotating as part of the Earth at 460 meters per second velocity, like this. Here, rotating together. Yes. Two. Now, think of that. Think of that now. Two different masses, red and green, two different masses objects rest against the hand. Greater mass object is, say, M1. And smaller mass object is, its mass is M2. Bigger one's mass is M1, smaller object's mass, small mass is M2. So, green objects, M1 objects, the resting against part of hand, this side, okay, this side, here. Where is green? Where is green? Here. Bigger mass in my hand, like this. Then smaller one here. We are rotating together. with the Earth as part of Earth, 460 meter per second, okay? But while we are rotating together at 460 meters square, red one, mass 1, pushback, then reaction from here, from my hand, reaction to smaller object, reaction force will be smaller than my hand's reaction to greater mass will be smaller. My hand reaction force to red one will be smaller than my hand's reaction to greater green one mass. Okay. Because of while rotating these two different masses, has actions to my hand, different actions and different reactions. Then, intrinsically, these two masses has momentum. Okay. Now, and once the resting against part of hand reacts with greater force, F1, then M2's second, the resting against part of hand reacts with smaller force on M2. Okay, different forces, different reaction forces from this hand. Okay, there are forces, yes, this is inertial rotation, intrinsic rotation. This is rotation velocity, for all of parts. Okay. Now, all of them is going on to rotate as part of the Earth at 460 meter per second velocity. When the two different masses objects are dropped, say left, released, not throwing, they are rotating together. No extra adding force on these objects. Free, release, drop. Don't push, no extra force, no adding force. They have different F1, F2 reaction forces. Yes. 3. When the two different masses objects are dropped, left, released, this means their initial and inertial velocity is same, but their momentums are different. Here P1, here P2. P1 is equal to m1 multiplied by velocity of rotating Earth, and P2 is equal to m2 multiplied by same velocity. Okay? P1 greater than P2. m1 greater than m2. Here. Okay. Therefore, A, if there was no gravity, this is here. If there was no gravity, these two different objects would orbit around. If there was no gravity, these two different objects would orbit around the Earth in same orbit as the two geosynchronized satellites, that they have same velocity facing Earth's same certain point with their own different masses and different momentums. Different masses, different momentums. Think of satellite, like satellites, that they have different masses, different momentums, same velocity, Earth velocity. And because of that, they don't need extra fuel. Spontaneously, they go on, rotate with the Earth, and they face same point. Okay, if there is Turkey or Italy or Cyprus or Bosphorus, always they're facing Bosphorus. Okay. With their own different masses and different momentums. B. Because of gravity, they fall to the Earth. Now, B. Because of gravity, they fall to the Earth at the same time, and their trajectories parabolic paths are the same. Wait a moment, please. Yes, same. Okay. C. If they didn't have initial velocities, they would fall to behind of the tower what they left for. Eventually, when they start to fall, they have different initial momentums, and because of their different momentums, although their masses are different, they fall to the ground at the same moment. I advise you to read this writing under this video, and I advise you to watch my previous video and former videos. Have a good evening. See you later.